Okay, we're going to look at the side of your worksheet that says Looney Tunes. Basically, we are going to be finding velocity sometimes, but also some acceleration. So let's look at the difference between these things. Velocity, you guys should be pretty familiar with. Velocity is distance over time. Acceleration is a change in velocity, and so acceleration is going to be the final velocity minus the initial velocity. So the velocity something ends at minus the velocity it starts at, divided by time. Okay, so if we want to find velocity, we'll use this one. If we want to find acceleration, we will use this one. Let's look at question 1. Bugs Bunny is running from Elmer Fudd. If he runs 250 meters, that's a distance, in 125 seconds, that's a time. What was Bugs Bunny velocity? All right, I want to find V. So I'm going to use this older familiar formula. Okay, so velocity equals distance over time. Distance is 250. Time is 125 seconds. I'm going to use my Desmos calculator to figure this out. 250 divided by 125. My answer is 2. So V equals 2. Distance was meters, time was seconds, so it's 2 meters per second. Okay. There's an example of velocity. Sorry about that bell. Number 2, Wile E. Coyote is chasing the Roadrunner at 120 meters per second. Meters per second is a velocity. The coyote suddenly runs into some glue he placed on the road to catch the Roadrunner. He slows to 2 meters per second. That's also a velocity. If I look at these two velocities, I can tell from this little story that this is the velocity he's going at first, so it's the initial. This is the velocity that he ends up going. It's my final. And he slows down that much in 5 seconds, that's a time. So what is his rate of acceleration? Acceleration, I'm going to use this one, and I have everything I need to do it. My V final is 2. V initial is 120. And my time is 5 seconds divided by 5. And that will give me acceleration. Let me go to my Desmos calculator again. All right, so I have 2, let me clear. 2 minus 120. That's giving me negative 118. You know what, and actually I'm going to put these in parentheses. So 2 minus 120 divided by 5. Negative 23.6. Negative 23.6. Does it feel kind of weird I got a negative number? Not really, because I can see that he's slowing down. He's going really fast at first, then he ends up going slower. And so it makes sense that this acceleration is negative. If something is slowing down, acceleration is going to be negative. Okay, units for acceleration. If my speed is meters per second, I have meters per second on top, but also seconds again on the bottom. So acceleration is going to be meters per second squared. The seconds end up being squared. Okay, let's look at one more. Yosemite Sam is riding his horse. He's heading off a cliff. He hollers, "Whoa, horsey, The horse stops and Yosemite Sam flies over the cliff. As he falls, he goes from 0 meters per second. That's velocity, and it's an initial velocity, to 49 meters per second. That's my final velocity in 5 seconds. That's a time. What was his rate of acceleration? Again, I'm going to use my acceleration formula. So acceleration equals the final, which is 49, minus the initial, which is 0, divided by time, which is 5. 49 minus 0 is just 49. So let me check in my calculator. 49 divided by 5. 9.8. And this time I ended up with a positive answer, and that makes sense to me because he's speeding up, right? He's not moving at all at the second that he first starts falling over the cliff. And then by the time he hits the ground, he's going faster. So he has accelerated, he has sped up. So it makes sense that this would be positive. Again, since my units were meters per second for velocity, but this is an acceleration, my units are going to be meters per second squared. Okay, continue through this worksheet. Call me if you need help.